Hi everyone, Assalamualaikum. In this video, we are going to discuss example 5 under area between curves. The following diagram shows the curve y equals to 2 over x here, right? And the straight line here, y equals to 3 minus x, right? Which meet at the point A and B. Number 1, find the coordinates of A and B here. And number 2, determine the area of the shaded region here. Right? First, we look at question number Roman 1. Find the coordinate of A and B. Right? Alright, since the coordinate of A and B are the intersection points, so to solve the intersection point, we need to solve simultaneous equation, right? Alright, first we have y equals to 3 minus x. We're naming it as equation 1. And then y equals to 2 over x. We're naming it as equation 2. Okay? And after that, we substitute equation 2 here into equation 1. Okay? We substitute 2 over x, which is equals to y here. We substitute into y in equation 1. So after we substitute, we get 2 over x equals to 3 minus x. Okay? And then to eliminate denominator x here, we can multiply both sides by x. Okay? When we multiply by x, so we get 2 here equals to 3x minus x squared. Okay? This is quadratic equation. To solve quadratic equation, one side should be 0. And then we need to rearrange. First term should be term containing x squared. The second term should be term containing x. And the third term should be constant. Okay, let's say we bring all the term to left hand side. So we get positive x squared minus 3x plus 2 equals to 0. Right? So from here, we can factorize. So when we factorize, we get x minus 1 times x minus 2 equals to 0. When we equate each factor to 0, so we get x equals to 1 and x equals to 2. Okay? Since we want to find the coordinate, so after we find the values of x, we need to find the values of y. Okay? So when x equals to 1, we substitute, let's say, into equation 1. We can substitute either into equation 1 or equation 2. Okay, let's say we substitute into equation 1. From equation 1, we have y equals to 3 minus x. Okay, now we replace x equals to 1. So after we simplify, we get y equals to 2. Alright? And then we substitute x equals to 2, let's say, into equation 1. From equation 1, we have y equals to 3 minus x. So now we replace x equals to 2. Okay? So after we simplify, we get y equals to 1. Okay? Since the question is find the coordinate, so we need to pass the values of x and y. Okay? Alright, so from here, we get a, coordinate A equals to 1, 2. Okay? When x equals to 1, y equals to 2. Why we choose A coordinate 1, 2? Because A on the left side. So means that from either x equals to 1 and x equals to 2, x equals to 1 is the smallest number. Okay? So we choose x equals to 1 as coordinate of A. And then when x equals to 1, so y equals to 2. Okay? And then the other one is coordinate B. Okay? B equals to 2, 1. Okay? We write coordinate x first, and then we write coordinate y. Okay? So this is the answer for coordinates of A and B. Alright? Alright, now we continue with question Roman 2. Determine the area of the shaded region. Okay? Alright, from here, okay, we have two formulas for area. Okay? First, integrate with respect to x, and second, integrate with respect to y. Alright? Alright. Let's say we check integration with respect to x. Okay? From the intersection point here, okay, we have two intersection point here, and then we draw a line to x-axis here, and there is no line that cross the shaded region. Means it's suitable to use area using integration with respect to x. And at the same time, it is clear that this is top function and this is bottom function. Okay? Alright. So let's say we use number 1. Okay? Area using integration with respect to x. Right? Alright. From here, so we have area equals to integration from x equals to 1, lower limit, and x equals to 2, upper limit, okay, and then top minus bottom dx, okay. And then when we use top minus bottom, okay, we need to write in terms of variable x, okay. And to write in terms of variable x, we need to write this equation as y is a subject, okay. Alright. And then x equals to 1 and x equals to here means lower and upper limit on x-axis. Okay, when we use top minus bottom means we need to write all in terms of variable x, and at the same time we use limit on x-axis. Alright. Okay, after that we have area equals to integration from 1 to 2, and then top function we replace by 3 minus x, okay, and then minus bottom function here we replace by 2 over x, okay, and after that we get integration from 1 to 2, 3 minus x minus, okay, we can write 2 times 1 over x, okay. After that we integrate with respect to x, okay, and after we integrate, no more integration sign. Alright. Okay, so we get area equals to, we integrate 3 with respect to x, so we get 3x, and then minus, we integrate x using power rule, so we get x squared over 2, and then we have constant 2 here. So when we have multiplication by constant, we just keep the constant in front here, and then we integrate 1 over x, okay. Alright, when we integrate 1 over x, we cannot use power rule, okay, but the answer equals to ln x, because when we differentiate back ln x, we will get 1 over x, okay. So the formula for integration of 1 over x equals to ln x, okay. And then since this is definite integral, so no need to write plus c, but we must put square bracket with lower and upper limit, okay. And then we replace x by upper limit first, and then in between minus, and after that we replace x by lower limit, okay. And ln 1 means 0, so 0 times 2 equals to 0. Okay, and then we simplify, okay, so we get this, and the final answer equals to 3 over 2 minus 2 ln 2, okay. We can leave the answer here like this, or we can use calculator, then we get decimal value, so we get 0.1137 up to 4 decimal places. Then we need to write unit squared. Right, for area. Square here means for area, right? And from here, we can see that area always positive, right? So this is the final answer. You can write this or this, right? In the previous slide, we determined the area of the shaded region using first formula, okay, which is integrate with respect to x. Okay. For this question, we also can use the second formula, integrate with respect to y. Okay. Because from here, from the intersection point here, when we draw a line to x-axis, okay, the line not cross the shaded region. And, okay, from line here and curve here, it is clear that the line always on the right side, okay, and the curve here always on the left side, okay, for the shaded region. Okay, don't refer this, but just refer the line and the curve bounded by the shaded region only. Okay, so when it is clear right and left, so we also can use integration with respect to y. Right? Right. If we integrate correctly, so we will get the answer exactly equals to when we integrate using the first formula. Okay, for this question, right? Alright, so now we try to use the second formula. Okay. Alright, area equals to y equals to 1 and y equals to 2. Okay, y equals to 1 is our lower limit from this coordinate. Okay, 1 here means y equals to 1 and 2 here means y equals to 2. Okay, so integration from y equals to 1 to y equals to 2, and then when we use lower and upper limit on y-axis, we need to use right minus left. Okay, dy. Okay. Alright, and then when we use right minus left, or when we use limit on y-axis, all terms should be in terms of variable y. Okay, and to write in terms of variable y, okay, we must write x as a subject. So from here, okay, we move x here to left hand side, so we get x equals to 3 minus y, and we move y to right hand side, so we get this. And from here, we just cross multiply here, okay, then we get x as a subject equals to 2 over y. Okay, when we write in terms of variable y, means that x must as a subject. Okay, alright, and then y equals to 1 and y equals to 2 here, we use lower and upper limit on y-axis. Okay, alright. After that, we have area equals to integration from y equals to 1 to y equals to 2. We replace right function here equals to 3 minus y minus the left function equals to 2 over y. Okay. Alright. Then, now we get all terms in terms of variable y. Okay. So, area equals to integration from 1 to 2. And then we can write 2 over y here. 2 times 1 over y. Okay. Then we can integrate with respect to y. Okay. And after we integrate, no more integration sign. Okay. So, the area equals to, we integrate 3 with respect to y, we get 3y. Minus, integrate y with respect to y, using power rule, we get y squared over 2. And then minus, we have constant 2 here, multiply by 1 over y. When we integrate 1 over y with respect to y, we get ln y. Okay. And then, since this is definite integral, so no plus c, but must put square bracket with lower and upper limit. Okay. And after that, we substitute upper limit first into variable y. In between must minus sign. And then we replace 1, lower limit 1 into variable y. Okay. And ln 1 equals to 0 times 2 also equals to 0. Then we get 6 minus 2 ln 2 minus 3 minus half minus 0. Then we simplify, so we get area equals to 3 over 2 minus 2 ln 2. Or in decimal, we get 0.1137. Correct to 4 decimal places. Okay. And then we must write unit. And for area, we must write square. Okay. And from here, we can see that area is a positive value here. Because area always positive. Alright. So this is the final answer. When we integrate the same question, but this time we integrate with respect to x. Right? So in this question, we can use either integrate with respect to x or integrate with respect to y. Because from this region, it is clear that the line is the right function and the curve is the left function. And at the same time, the line is the top function and the curve is the bottom function. This one is top, this one is bottom. And at the same time, this one is right, this one is left. Right? Got it? Coming up next, volume by this. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.